when we are doing testing at lab, okay, or at R&D center, what we are using, we are not going to use this diagnostic tool, right? Correct now? We are going to use CAN testing tool. Yes or no?
Yes, sir.
Everyone? We are going to use this diagnostic test tool, right? So during our course, we are going to see two testing tools. One is Canalizer, another one is CanAPIL. Okay. So Canalizer, what is the use of Canalizer? Anybody? I gave 3 points, right? Guys,
Simulation of CAN message, sir.
ready. This is first point. Second point.
Monitoring CAN bus.
Yes.
testing. UDS testing.
Yes. So using Canalizer, even we can monitoring the CAN bus. What is going on the CAN network? Who is transmitting what information, what messages? Everything we can monitor using Canalizer tool. And the third point is performing UDS testing. Correct now?
Yes, sir.
Now just tell me what are the input files required for Canalizer?
DBC file, sir.
Yes. DVC file, why it's required? Because DVC file will have all the CAN related information. Entire CAN matrix information will be present in the DVC file, right? What message, who is transmitting that message, correct? Huh? All kind of information. And if we'll see, this DVC file will look like this. See, I'm telling you this again and again because these are very important things. You need to understand. Okay. Clear
Ravi,
now?
I think you forgot to record.
Okay. Yeah. Okay. From now at least. I will start
Recording in progress.
recording. Okay. I will start recording. So
Okay,
this
Ravi.
is the DB. Yes, Ram?
Yeah, it's okay.
Okay. So this is the DVC file. Is it visible, right?
Yes, sir.
Yeah. So this DVC file is CAN database file. All the CAN related information which are required by our ECU.
Hello, hi, and good morning.
Either it can be TX, either it can be RX. Transmitted message by our ECU or whatever the messages which are received by our ECUs from other nodes. All this information will be provided in this CAN DVC file. This will be the input for developer for designing the CAN network. Okay. And this will be the input for tester for performing tests. So this is very much required. Is it clear, guys? So what kind of information will be there in the CAN database? Message, even in message, what all signals are there? Okay. If we'll talk about message, what is the name of message being used? What is the message ID, that unique message ID for that message? What is the format? Is it CAN standard format or extended format? What is the DLC of that message? What is the transmission type, or sorry, method? I mean, is it cyclic or is it event based? If it is cyclic, what is the cycle time? Okay. Which node is responsible for transmitting this message? Okay. Clear now? So all this information will be there in the DVC file. Now for this message, what all list of signals are available? Okay. Even we can open individual signals and we can check related information. Okay. This signal is from which message, what message ID, what is the cycle time related to this signal. all properties like what is the initial value, what is the factors, okay, who is the receiver of this message, okay. For this signal, what are the value description? These are enumerators value. If this signal's value is 0, that means SB not monitor. If its value is 1, that means SB unfasten. So such kind of information you can see in the DVC file. Based on this, the developer is going to develop the CAN network. Based on these information, tester is going to test the ECU is standalone. Now, when the tester is going to test the ECU, it has to first prepare the setup, right? Setup has to be prepared. What all things required to run our ECU is need to figure it out, right? What all things required? If we'll talk about the ECU, we need to have the power supply, right? We need to power up the ECU first. After powering up, we need to have a CAN network simulation, right? Correct, na, guys? Hello? Guys, able to hear me, right?
Yes, sir.
So understood now? First, we need a power supply to powering up the ECU. Then we need all the sensor or actuators that will be there with the ECU. Not a problem. Apart from that, we need what we need? We need the vehicle network because we are testing the ECU standalone. We doesn't have the entire vehicle with us, the lab. Okay. So in that case, we are using one of the property of Canalizer, simulation of CAN messages. Understood? For that purpose, we are going to import that DVC file. Once this DVC file is imported, all the CAN database related information will be imported to the Canalizer. Okay. Is it clear? Guys? Good. So now this portion is used for simulation of CAN messages. And this portion of the Canalizer or Windows, I can say, is used for monitoring the CAN network. Correct? Okay. So this part is clear, right? Now this simulation of CAN bus, how we are going to do that we'll see when I'm going to take classes on CAPL. Okay. That time we'll see in detail. Currently, we are just trying to figure it out or just trying to understand how this UDS is working. Okay. Clear now? Guys, this detail will go how this simulation is going to be done on Canalizer tool that we'll see in detail when I'm going to take classes on CAPL script. Okay. For time being, our intent is to understand how this UDS testing is performed using Canalizer. Am I clear? Guys?
Sir.
Clear now? Yes, no?
Yes, sir.
Okay, good. इन कैसे करेंगे यार? Yeah. So see, this is the Canalizer, okay? Now I told for performing diagnostic related testing, we need another file. What is that file? Guys?
CDD.
Yes, good. .cdd file, Candela diagnostic description file. Okay, na? So using that CDD file, first we need to create the diagnostic console. Okay. So here we have imported the CDD file and we have created a diagnostic console. This is the diagnostic console we have created. Okay. Now using this diagnostic console, whatever the services implemented in CDD file will be imported in the Canalizer tool. Okay. Like in CDD file, it will be mentioned what all services supported by this project. Let's say we have session control. Yes, it is supported. So all the session control, default session, programming session, extended session will be implemented. Now we have security access level 1. So 2701, 2702 is implemented. Okay. So now we have others, ECU reset, communication control, routine, IOS, variant coding. So there are a lot of things which are supported for this project. Based on that, the developer is going to create .cdd file. Okay, that is the responsibility of development team, those who are working on diagnostic. They will create this CDD file. Okay, because this CDD file will be the input for developer also when they are developing the code using some tools like diagnostic DaVinci configurator. So they are using this CDD file as an input to do the configuration of these services. Okay. So this will be the input for development team as well. And this will be the input for our testing team to perform the diagnostic tests. Okay. Till here, is it clear how we can generate this diagnostic console? Guys? Guys, any doubt? Please do let me know. Again, I can explain it.
Sir, would you repeat once again, sir?
Okay, fine. See, this is the Canalizer configuration, right? For testing UDS, I told we need to have CDD file also for testing UDS. Okay, that CDD file, is the path is here. So this is the CDD file, Candela diagnostic description file. Okay, if you'll open it, so this also can be opened. Okay, it will open in Candela Studio. That is a tool. Okay, Candela Studio version 19. Actually, at the time of installation, I did some mistake. I installed in German language. Okay, so when we are opening it, it's showing in German. Okay, so this is the CDD file. Okay, which is created and developed in Candela Studio. This is the tool which is used to design and develop. Okay, so if we'll see now, like if we'll talk about diagnostic on CAN, all these information will be put in here. Like what is the P2 server time, right? Do you remember for 10 service P2 server time that we are going to configure it? P2 star server time, okay? S3 client time. So there are a lot of information this developer team is going to put in this. Request can ID message A1, response can ID message B1. Okay, so the request will be made using A1. Okay, this is physical request. Can you see here in description? The request can identifier for physical request. Response will be using message ID 0xB1, and functional request will be the request can identifier for functional request using message ID 0xE0. So all this information will be given based on the CAN description or CAN requirement which is provided by the OEM in this CDD file. Okay, and then this CDD file is used for development team for develop the diagnostic related services, and testing team we are using this CDD file will import in this Canalizer. Okay, see the CD file we have imported, and once we'll import it, this diagnostic console we can able to create. Okay, if we'll see in detail, so after import now you will see whatever those information that will be seen here. Okay, whatever the information which is there in this file, everything will be imported here. Okay, all the information will be imported here. P2 client time, P2 server time, S3 client time, S3 server time. All the information from that CD file will be imported in the Canalizer. Is it clear? Now, apart from that, all the related information related to services, okay? If we'll talk about services, it's identifiers. These are the DTCs related information. Actually, German mein, that's why all related to services information also will be there. Okay, like if we'll talk about session control. So session control, we have 3 sub-function implemented. Okay, that information will be fed here. Default session 01, programming session 02, extended session. Okay. If we'll talk about this identification V number, these are the DIDs. We have security related information. So security level 1 only implemented, 01, 02. Okay. If we'll talk about ECU reset, so this is the ECU reset. Okay, reset request. In this reset request, 2 types are implemented. 01 subfunction hard reset, 03 soft reset. So this project supports only 2 types of reset request, hard reset and soft reset. So all this information, my intent is just to show you all this related information will be first implemented in the CD file, and then this CD file will be used for development team to develop the related diagnostic services and DIDs. Okay, and this CD file will be used by testing team for performing QTS testing. Correct now, guys? Is it understandable? Okay, first time I agree, but this will I'll keep on every time interval. I'll show you this CD file. Okay, don't worry. It's not just one time. I'll show you again and again. Okay, na? Guys?
Okay, sir.
So at least by first time, what all services we have seen? Tell me. Session control, right? Correct now?
Yes, sir.
In session control, 3 subfunction: default session, programming session, and we have seen extended session, right?
Sir.
Correct now? So see, if we'll talk about this, if we'll talk about this session, what should be the positive response? So like this will be implemented. Okay. Here we'll implement. Positive response will be 6 byte. Okay. In that P2 server time, P2 extended server max time. That is start max time is extended time. This information will be part of parameter ZZ. Positive response first 2 byte is 5002. Okay, for programming session. For extended session, positive response will be 5003, and this ZZ. So ZZ is P2 server time, P2 extended server time. So these all information will be there in the CDD file. Okay, if we'll talk about negative information, negative response, we have these negative response. So there are 10 and 11 also there. Okay, service not supported, 12 subfunction not supported, 13 incorrect message length, invalid format, 14 response too long, 21 easy repeat request. So there are these many list of NRCs. Okay, these are the list of NRCs which is supported by UDS. Okay, now when we'll implement the services, we'll implement what all the NRCs has to be implemented. Okay, understood, guys?
Yes, sir.
Understanding now?
Yes, sir.
So all what should be the positive response format? What should be the negative response? Everything will be described in this CD file. Okay, if you'll talk about, let's say, issue reset request. Okay, so in reset request, what will be the positive response? So only 2 byte of positive response, 5101. For soft reset, again 2 byte of positive response, 5103. That's it. Clear?
Yes, sir.
Understanding, right? Yes or no?
Sir.
Okay. So likewise, for all the services, they will define here itself what should be the positive response, if what should be the negative response. So negative positive response will always start with 5001 ZZ, ZZ explanation they will give it here. Okay. If we'll talk about negative response, can you see here 7 here? It's coming now. Negative response 7F 10 RC. Okay. That RC related information, you will see it. This is mentioned in German now, so it's difficult to explore. Okay, so difficult to explore it here, but okay, no problem. This RC related is what are the negative response code implemented for this, that RC information will tell. Okay, the format definition, how the negative response will come, that will be given. Clear now? Same thing for security access. So see, security access, the request will be of 2701. The response will be 6701, and this ZZ. ZZ is the security seed, hexadecimal 4 byte. Understood? If we'll talk about 2702, the request will be 2702YY. What is this YY? This is the security key, hexadecimal 4 byte. Okay, and the positive response for this will be 6702. Understanding now, guys?
Yes, sir.
So all this information will be there in the CD file. Okay, now at least little bit you understood about the CD file, what all information will be there,
Yes, sir.
guys? Okay. So based on this information, using this canalizer, we are going to test it. Okay. So we have ECU connected. Okay. So now we'll open this CD file and we'll try to request for let's say extended session or programming session. Okay. We'll request for programming session. See, when we send request, we got negative response, condition not correct. Okay. So now let me open this trace window. Okay. Is it visible, this trace window?
Yes, sir.
See, the diagnostic tool has sent the request to the meter. Okay. Meter is nothing but this instrument panel cluster. Okay. Using message ID 741, this is physical message ID. Okay. The client is sending request. Client means diagnostic tool is sending request to meter using message ID 741. And what is the request? Request format is this 02 single frame 2 byte DLC 1002. Okay, and this is padding value. Able to see this, right?
Yes, sir.
Right now? Okay, and then using message ID 763, meter is sending response to the diagnostic tool. 743 message ID is used for diagnostic tool is sending request to the meter. 763 message ID is used when meter is sending response to the diagnostic tool. Okay, using this message ID, meter is sending response, either positive, either negative. What is the response here? The response is negative response. 3 by DLC 03 7F 10 22. 22 is what? What is 22? Guys, what is 22 in RC? Twenty-two is condition not correct. 33 is security access denied. Na? Forgot. 22 is condition not correct. Guys, remember? Guys, do you
Yes.
remember? So
Forgot.
condition not correct means, hello? Am I audible, right?
Yes, sir.
Okay. So condition not correct means either the vehicle is moving, right? Vehicle speed is more than 3 km per hour. Either voltage is not within the range. Either ignition is switched off. Correct, na? So we'll check. We'll check in the panel. See here, vehicle speed is coming 9 km per hour. Understood? Guys? Understood, na?
Yes, sir.
This vehicle speed is coming 9 km per hour. Now we'll decrease the vehicle speed. Can you see the speed meter is showing something here, near about 10. So now we'll decrease the vehicle speed. Now we'll make it at 0. Clear?
Yes, sir.
Guys, now the vehicle speed is 0. Now we'll again use the diagnostic console to send the request. Still it's coming negative response. Why? Because here ignition is off. Correct? Now ignition is on. Voltage is within the range. Ignition is on and the vehicle speed is 0. Now again we'll send request. This subfunction not supported in active session. Do you remember I told from the default session, we need to first switch to extended session, then we need to switch to programming session.
Yes, sir.
Okay. So first we'll request for extended session. We got positive response. Now we'll request for programming session. Then we got positive response. Now we'll see the trace, how it happened. Okay. First we tried to send 1002, but the server has checked, condition is not correct, it sent negative response. Okay, the vehicle speed was high. Now second time again we requested 1002, but still we got negative response because the ignition state was not turned on. Clear? Clear now? Guys? Is it clear?
Yes, sir. It's clear, sir.
Then we again, after making the ignition state on, again we requested programming session. But as I told, programming session is not supported in default session because we turn on the ignition. The active session is default session. Okay. In default session, when the server is, we cannot request programming session because programming session can be achieved when the server is in extended session, right? Clear now? That's why we got here 7F, 10, 7E. This means sub function is not supported in active session. 7E का मतलब यही है ना, NRC code. Turn your page, check it. What is the meaning of 7E? Guys? Am I audible? Hello?
Yes, sir. Audible, sir.
Have you turned your page and check what is the meaning of 7E NRC?
Subfunction not supported, sir.
Subfunction
Not supported, sir.
not supported in active session.
Yes, sir.
Subfunction not supported is NRC 12, right?
Yes,
Right,
sir.
no?
Yes, sir.
Everybody understood, right? So now client has requested to switch to extended session from default session. Then we got positive response 50.03.0032.01 F4. That means now the server is in extended session. Then again client has requested to switch to programming session by sending request 1002. Now the server has switched to programming session. Before that, it sent the positive response 50.02.0032.01 F4. Clear? Everyone, is it clear?
Clear.
Clear, sir.
Okay, that's how this UDS works. Okay, I will let's say again, if the vehicle speed is increased, okay, increase to 10 kilometer or maybe 14 kilometer. Okay, and now again from programming session, maybe client has requested to switch to extended session. Again will come condition not correct. Or let's say we'll use to transmit, let's say 10 0301. Okay. We'll send incorrect message length because we are sending 3 byte of request, right? Understood now? The client has sent 100301. Then after receiving, server will give response, negative response, incorrect message length or invalid format. Understood? Now again, we will switch to 0 km/h, the vehicle speed, and then we'll request session to default session. We'll get positive response. P2 time is 50 millisecond. P2 extended time is 5000 millisecond. Is it clear? Now if you'll see in the trace window, here, we try to send request 100301. We got negative response, invalid message length, or incorrect format. Then again we requested with correct format 1001, and the server switched to default session with positive response. Understood now? Guys?
Yes, sir.
Is it understood, everyone?
Yes,
Now
sir.
let's say if you request 1004, what will be the response? Is it positive or negative? Guys, will it be positive response or negative response?
Negative response, sir.
What will be the NRC code?
Subfunction not supported.
Yes, NRC code will be subfunction not supported. And if you'll see in the trace window, you'll see 7F, 10, 12. 12 is subfunction not supported because client has requested 1004 and 04 subfunction is not implemented in the project. So server will say, I will not able to switch in 04 session. What is the reason? Reason is NRC code 12, subfunction not supported. Understood, guys? So now is it clear? I mean, how it's working, how this diagnostic is working, how client is sending request to the server, and based on the server request, whether server can serve that request, then we'll send the positive response. If server due to some reason will not able to serve the request, then we will send negative response with NRC code. Is it making sense, guys? Clear now? Everyone? Any doubt? Any doubt? Yes, no? बोलो कुछ डाउट है क्या? Guys, do you have any doubts? Now we'll see for this ECU reset request. Okay. Here, ECU request is protected by security. And when the client tried to access this, the server has given negative response with NRC code security access denied. Understood? For that, first we need to go to extended session. Then we need to access the security. Okay. Invalid key. So the key being sent is invalid. Okay, to check.